I wanted to take a moment and go over one of your homework problems. And so the following problem says, the reaction of the body to a dose of medicine can sometimes be represented by an equation of the form R equals m squared times the quantity C over 2 minus m over 3, and that quantity, where C is a positive constant and m is the amount of medicine absorbed in the blood. If the reaction is a change in the blood pressure, R is measured in milliliters of mercury. If the reaction is a change in temperature, R is measured in degrees, and so on. So we want to find the amount of medicine to which the body is most sensitive by finding the value of M that maximizes the derivative dr over dm. So the first thing that we want to do, actually the first thing I would probably do, is take my equation M and rewrite it. Let's distribute that M squared. And so doing that, we get R is equal to CM squared over 2 minus M cubed over 3. So I just distributed my m squared inside my parentheses, which will make it a little bit easier to take the derivative. That way I don't have to use the product rule. Remember that C is just some constant. And now we can take the derivative of R with respect to M. And so taking the derivative with R with respect to M, we get 2CM all over 2 minus 3M squared all over 3. And so cleaning this up a little bit, notice that the 2's cancel here and the 3's cancel here, and we're left with CM minus M squared. It wants us to maximize the derivative. And so in order to see what maximizes something, we want to take the derivative. Well, because we're trying to maximize the derivative, we want to take the derivative of the derivative. So we need to take the second derivative. So taking the second derivative of R with respect to M. So derivative of CM is just C minus the derivative of M squared is 2M. So recall, to find our critical values, we set that derivative, in this case our second derivative, equal to 0. And so if I look at this, I get C is equal to 2M, or M is equal to C divided by 2. So let's see if this maximizes this. So we can look at the second derivative test. In this case, it would actually be the third derivative, to see if this is a maximum or a minimum. If I took the third derivative of C minus 2M with respect to M, this would just give me -2. So notice this is always less than 0. So that told me this was concave down everywhere for the derivative function. And that C over 2 then is going to be a maximum of my derivative. So M equals C over 2 is what maximizes the derivative. Which we can denote as dr over dm. So this was number 24 on 4.6 of your homework. So hopefully that explains how to do that. I think that the key here was that we're trying to maximize the derivative and not the original function.